students. Today we are going to study the basic construction, working and characteristics of Triac, the another member of the Thyristor family. In the previous lecture, we studied the construction, working and characteristics of the silicon control rectifier. Triac is another member just like SCR. Triac is basically triode AC. It is a 3-terminal AC switch. Let us see what the triac is. The triac is derived from triode and AC. It is a bidirectional AC switch, works in both directions. SCR में क्या था? It was working only a single direction, एक ही डायरेक्शन में काम कर रहा था when it was forward biased, but in case of reverse it was not working, only small current was flowing due to reverse saturation charge carriers, reverse saturation current basically. Triac has the following advantages over SCR. Triggered with positive or negative polarity, it works for both the polarities, positive and negative, but SCR was working only for the positive polarity. As Triac needs a heat sink which is larger than SCR, but in case of SCR we need two heat sinks. It needs a single fuse for protection, which simplifies the construction. In some DC applications, we need to connect a parallel diode with SCR to protect against reverse voltage, but in case of Triac, this works without diode. So in case of working, when we want to work in reverse region, then Triac is much safer than SCR. Let us see the construction and working of Triac. As I already said, it is a 3-terminal AC switch. The construction is, the layers are P1, N1, P2, and we have divided N layer in two parts. One makes one terminal, another N3 layer, it makes one another terminal. These terminals are known as main terminal 1 and gate, and on another side we have diffused a small N4 region, and the terminal is named as main terminal 2. So you can see three terminals are there: main terminal, empty 1, empty 2 and gate. We can also understand this Triac with two SCR connected in anti-parallel direction. You can see here two SCR, P1, N1, P2, N2, P2, N1, P1, N4. So this is how we can interpret any Triac with two SCRs which are connected in anti-parallel. The working of Triac is somewhat same as that of SCR. In case of SCR, we had already seen the current will start increasing when the applied voltage, उस केस में क्या किया था, we applied a voltage between anode and cathode. So when the applied voltage was more than the breakover voltage, only then the SCR was conducting. Here also, when the applied voltage will be more than the breakover voltage, it will start conducting. We have 4 cases over here to make understanding of the how the working of Triac will takes place. This is the schematic symbol of Triac. Let us see all the 4 cases or the 4 mode of operations for SCR. We have the possibility of 4 cases. कौन सी empty 2 and gate are positive, empty 2 and gate are negative, empty 2 is positive, gate is negative, empty 2 is negative, gate is positive, and so on. These are the 4 cases, and we will see the working or conduction of the Triac in all these 4 cases one by one. The very first case is empty 2 is positive and gate is also positive with respect to empty 1. So we have applied a voltage supply between empty 2 and empty 1, and the positive terminal is connected to empty 2 because we said empty 2 is positive with respect to empty 1, and the gate will also be positive. So this is the supply connections of the triac. Under this condition, what will happen? The gate current will flowing through P2 and 2 because this junction is forward bias. So my gate current will be flowing through P2 and 2. Let us see what happens to the junctions. Due to connection of this supply, this P1 and 1 becomes forward bias, and P2 N2 also becomes forward bias, but N1 and P2, this junction is reverse bias. So when the voltage is below the breakover voltage, the triac will not conduct. But as soon as this voltage go on increasing, or you can also increase gate voltage, as soon as this voltage go on increasing, this junction will break down and current starts flowing through the triac. And what, through which path it will be? The current will be flown? It will be flown through P1, N1, P2 and N2. So when gate is empty 2 is positive and gate is also positive, the flow of current will be in the direction P1, N1, P2, N2. It is very much clear from this structure and by the biasing strategy which we have used, that the direction of the current is this P1, N1 and P2, N2. Let us see the second case when empty 2 is positive and gate is negative with respect to empty 1. It means what? The supply connections between empty 2 and empty 1 are same as that of the previous case, but now we have changed the polarity between gate and empty 1. So what will happen now? Under this condition, gate current will start flowing through the path P2 and 3 because due to this gate voltage, this junction P2 and N3 will be forward bias, and the current will conduct through P1, N1, P2, N2. What is the difference from the previous case? In this case now, P2 and N1 is also forward biased. P2 and N1 is also forward biased. So current carriers injected into P2 makes the triac on. Let us see the third case. Same direction is same as that earlier. In the third case, empty 2 and gate are negative with respect to empty 1. Now, empty 2 भी हमारा negative हो गया है, gate भी negative हो गया है. What will happen? This one. In this case, N3 acts as a gate, remote gate, and injects current into P2. And external gate current forward biases P2 and N3. External gate current will make it forward bias through due to the connection of this supply. So current will start flowing in this direction. Gate current will start flowing in this direction, P2 and 3. Here P2 and 1 and P1 and 4, these are also forward biased because P1 and 1 is reverse bias in this case because of connection of this supply. So current will start flowing through this path P2 and 1, P2 and 1, P1 and N4. So now the current path will be opposite to the previous case. The current is following in this direction from empty 1 to empty 2. Let us see the fourth case. Again in this case also we will see the current will start following empty 1 to empty 2. Under this condition, current gate flows through P2 and 2. Gate current will flows through P2 and 2. Here I have connected M2 negative terminal and gate is positive now. In this case, P2 and 1 and P1 and 4 both are forward bias, N1 from this connection due to application of this supply. The structure leads to turn on through the path P2 N1 P1 and 4. So this will be the direction of the current. So we have seen in first two cases the current was flowing through this path P1 and 1, P2 and 2, and in last two cases the current is flowing through P2 and 1, P1 and 4. So the current is following in both the conditions when it is forward and Triac is reverse, means we have applied positive terminal at empty 2 with respect to empty 1, or uh, positive terminal at empty 1 and negative as empty 2. So in both the cases the current is following, but the current will start following only when the voltage is more than the breakover voltage. This is the case when Ig is equal to 0. As soon as I go on increasing Ig, the current breakover voltage will come earlier and the current will start flowing at the earlier stages. Similarly for the negative also, when Ig is equal to 0 and we have negative voltage, the current will start flowing and will follow the same pattern as that of this quadrant. So in case of Triac, we have the current is flowing through in first and third both the quadrants, but in case of SCR क्या हुआ था, SCR के केस में हमारे पास सिर्फ इसी क्वाड्रेंट में करंट फ्लो कर रहा था एंड देयर वाज नो करंट इन द थर्ड क्वाड्रेंट. When the terminal empty2 is made negative with respect to empty1, or when the terminal empty2 is positive with respect to empty1. So this is the characteristics or behavior of the characteristics. In first quadrant the current is following when empty2 is positive with respect to empty1, and in the third quadrant empty2 is made negative with respect to empty1. In first quadrant case, the Triac is said to be working in forward blocking mode, and in case of third quadrant the Triac is said to be working in reverse blocking mode. So we can see the Triac is working in both the direction. That's why it is known as triode AC switch or three terminal AC switch, which works in bi-direction. दोनों directions में ये काम करेगा. These are the applications of Triac: high power lamp switching, AC power control, speed control of motors, in portable drills, temperature control, power switches, and many more.